Hello, my name is Reinhard Partmann, and in this video we are talking about how we can incorporate virtual SAN, or in short vSAN, into an Horizon physical storage design. So, what is vSAN? vSAN is a fully integrated storage solution which is baked into vSphere, right? So it's completely integrated, can be managed through the vSphere client, and it's software defined. vSAN sits in the data path, so we have no CPU overhead and all of the other stuff, and we can control the whole environment. We have two different types of vSAN. We have the cost-effective one, which is called the hybrid, and we have the real high-performance all-flash solution, where we have deduplication, compression, and RAID 5, RAID 6 enterprise class features available for us. This again, those erasure coding features reduce cost. As we already mentioned, vSAN is a feature of vSphere, and as you can see on the list, we have a lot of features there, right? So we have our hybrid and all-flash solution, we have the features deduplication, compression we already mentioned, which are only available in all-flash scenarios, right? We have storage policy management, we have native encryption, and from the scalability point of view, we are using local disks in our servers for vSAN, so if we need more capacity, more I/O and stuff like that, we just add another node to the vSAN cluster, right? So we get additional CPU power, additional RAM, additional disk space, additional I/Os, and additional network paths. Of course, there are some limitations like 200 virtual machines per host, 9,000 objects per host, and a vSAN cluster can be grown up to 64 hosts. Again, here a little product overview, how the whole system is comprised. We have our management layer which is controlled by vCenter. vCenter controls our virtual machines and our hosts, and also through the vCenter and the vSphere web client, we control and configure vSAN. When you look at the picture here, you see that we are leveraging local disks. Those disks are built in right into our server. So, what features do we have there? Like we already said, deduplication and stuff like that in all flash, and we have shared storage properties, like this would be a storage which comes out from a storage box. But let's have a little bit more detailed look into vSAN, because when you look at our hosts there, you see a standalone flash device, and then you see capacity device where it says HDD magnetic disks or SSDs. So how does this all work together? Well, in a vSAN cluster, you have optimally the same hosts. In each host, you have the same number of disk groups. So what is a disk group? A disk group consists of one performance device and one up to 7 capacity devices. So this performance device is usually a SSD. And the capacity device can be a magnetic disk or an SSD. So you see, again, we are back hybrid, where we have in the performance device an SSD and magnetic disks and the capacity devices, or all flash, where the performance device is an SSD. It should be a really fast one. And on the capacity devices, you also have SSDs. In one host, there can be up to 5 disk groups. Okay, so the total amount then would be, if you have one host with 5 disk groups, you have 5 performance devices and 35 capacity devices. All those disk groups over all hosts in your vSAN cluster will be joined together to the so-called vSAN data stores. And on these vSAN data stores, your virtual machines are being created. There are also some other differences between hybrid and all-flash, because now you know the performance device is always an SSD, so in a hybrid use case, which is a little bit more cost-effective, 30% of your flash device is being reserved for write buffering, and 70% are being reserved for read cache. In all flash scenarios, the performance device is used for 100% write buffering, and there is no read cache at all because, well, let's be honest, you already have SSDs as capacity devices, so the read latency is very, very low, and it's already blazingly fast, right? So, and from this aspect, the developers have chosen to shift the balance between read cache and write buffer there. With vSAN, we can use the help of storage policy-based management. So we have some storage policies, and those storage policies contain rules how the data should be managed within the vSAN layer, right? So we can categorize virtual machines or components of virtual machines. How should they be cached? How should the data be managed? How should the data be striped? How is the availability of those objects? As I already said, those storage policies have rules, and there are a set of rules within the storage policy. So we have data services, capacity-based rules, and also tag-based rules where should virtual machines be placed either on vSAN or on other data stores so that the tags match, correct? And with the data services rules, we can say, okay, we have a virtual machine which needs obviously a lot of power. We want to have a certain amount of that virtual machine always to reside in the cache layer and not on the capacity layer in the case of hybrid configurations. So another key aspect is when we talk about storage, we don't want to lose data, right? So availability is also a very key feature of vSAN. So normally objects are being treated with the safety of RAID 1, so that there are always two copies of that. So we have copy 1, copy 2, and a witness of the copy, so that we always can decide which one is correct, where can we read, what should we do. So, but all this is being handled by the vSAN layer, right? There are also other aspects we should take care of. How many copies do we want? So if we set the FTT, the failures to tolerate, this also goes how many copies are being created and how many hosts are needed. Okay, let's say we go for FTT equals 2. Well, how many copies do we have? And the formula you see on the slide is n plus 1. So we have 2 plus 1 equals 3. So we have copy 1, copy 2, copy 3, and our witness, right? If you look at the formula for the hosts, it's 2 times n plus 1. So n is 2, so 2 times 2 is 4, plus 1 equals 5. We need for FTT 5 to satisfy this requirement at least 5 hosts. And with this formula, you can then easily calculate how many hosts you need regarding the level of security and availability of your data you want to achieve. Since vSAN version 6.2, we have the failure tolerance method, and if you look at the slide deck, we have failure tolerates 1, RAID 1, and also with failure tolerate 1 is erasure 5 encoding, and failure 2 is with FTT 2 or RAID 6, right? But with RAID 5, RAID 6, which is also called erasure coding, don't forget you need at least with RAID 6 4 hosts, and you need all flash for RAID 5 and RAID 6. With RAID 1, however, you can have FTT 1, 2, or 3. But don't forget, even if you have RAID 1 with FTT 3, the formula still stands. 2 times 3 is 6, plus 1 is 7, at least 7 hosts. Keep that in mind. Here you can see how these failures and those RAID levels go together, right? And you also can see the number of disk stripes per object, which values you can set in the rules of your storage policy, right? So all of these rules come then together and tell the vSAN code how to behave, how to place, and how to copy the data, and or better to say, how to spread the data out throughout your vSAN cluster. And data security and data availability is one of the key features of vSAN. And again, if you look at the table here, the number of follow rates we take, or we better to say we choose regards in how many hosts we need, what are the capacity requirements, what is the capacity requirements for RAID 1, RAID 5, RAID 6, depending on the code in the backend which is used and number of hosts you have, you can select and choose what you want to do. And now comes the real cool part. You have your storage policy, and your storage policy has a number of rules in it. But the storage policy is not directed on the whole vSAN data store. No, it can be directed to the virtual machine components, namespace, disks, swap, and so on, right? So you really can have granular configurations for different virtual machines or a set of virtual machines. And if you think of traditional storages, how is the data protected there? You have a RAID setting for the whole LAN, so all virtual machines on that LAN have the same protection level. So basically what we are saying is we moved up the protection level setting, the cache settings, the optimization settings, and all that stuff to the VM layer from the storage layer. So now we can say not only we have one storage policy, no. For different components of our VM, we can have different storage policies. We must not, but we have the possibility if we need to be. Right? And this makes the vSAN model very, very flexible. So, with all that what we have heard now, what are the typical questions? Okay, should I have one or more disk groups? Well, depending on the size, the physical size of your host, how many drives you can build into your host, this is one aspect. And the other aspect is how many drives do you have? Let's say you have one SSD and let's say 3 magnetic disks. Then you can only create one disk group because the SSD is going to be the performance device and the capacity devices will be those 3 magnetic disks. So but if you say, okay, I would like to have 3 disk groups, you can do the following thing. You add 2 additional SSDs in that particular host, then you have 3 disk groups, and each disk group consists of 1 SSD and 1 magnetic disk. Which helps you a little bit because you have more capacity in your cache layer, right? Because instead of 1 SSD, you have now 3 SSDs. And if you remember the write buffer read cache ratio, you have now 3 times the write buffer and 3 times the read cache because you have 3 SSDs, right? So, what is the second question? Should I use deduplication and compression? Well, again, depending on your use case, it's always a good feature to have a longer lasting storage, or you can put more load on your virtual SAN. But never forget that deduplication and compression comes with an overhead, well, which is cost, CPU-wise. And on the other hand, it's only available on all-flash vSAN configurations. Third question, should I use the View Storage Accelerator, also known as CRVC, with the vSAN client cache? Short answer, yes. Why? Because they both perfectly work together, because the View Storage Accelerator is basically a cache in the RAM of your ESXi hosts, and when objects are accessed there, nothing is basically faster than RAM, right? So, having that said, I also have a couple of additional information for you regarding vSAN. The vSAN All-Flash Reference Guide, the vSAN Best Practices Guide, there is a vSAN Network Design Guide, and also the Horizon Enterprise Reference Architecture. There's a lot of information out there for you guys regarding vSAN and Horizon. And This topic is growing because vSAN is a very feature-rich, very stable and blazingly fast storage solution, and it's fully integrated into vSphere and can be administered throughout the vSphere HTML client and the